Imagine Earth, not as it is today, but as a world consumed by fire. This was Earth's reality billions of years ago during a time known as the Hadean Eon. The Hadean Eon, beginning around 4.5 billion years ago, was Earth's first geological period. This period was marked by intense heat, volcanic eruptions, and a truly alien environment. The very surface of our planet was a molten sea, bombarded by asteroids and comets. It was a time of intense chaos and transformation, the echoes of which still resonate in the geology of our planet today. It is within this fiery crucible that our planet's incredible journey began. The Hadean Eon gets its name from Hades, the Greek underworld. This name is fitting, as this early Earth would have been an incredibly hostile place. Temperatures were scorching, reaching thousands of degrees. The air was thick with noxious gases, far too toxic for any life we know to survive. The bombardment from space was relentless, each impact releasing even more energy and heat. Yet from this maelstrom, a planet would emerge. The Earth, along with the rest of our solar system, formed from a massive cloud of gas and dust called a solar nebula. This nebula, under its own gravity, began to collapse in on itself. As it collapsed, it began to spin faster and faster, forming a disk. At the center of this disk, the sun ignited, bathing the surrounding disk in light and heat. Within this disk, dust grains collided and stuck together, gradually growing larger and larger. These growing clumps of matter became planetesimals, the building blocks of planets. Over millions of years, these planetesimals continued to collide and coalesce, eventually forming the Earth. The early Earth was a very different place than the planet we know today. It was a hot, molten ball of rock and metal, constantly bombarded by debris from the early solar system. The energy from these impacts, combined with the heat from radioactive decay within the Earth's core, kept the surface of our planet in a molten state. This period is known as the magma ocean phase. As the Earth cooled, a thin crust began to form on the surface, but volcanic activity was still rampant. Volcanoes spewed lava and gases into the atmosphere, contributing to the incredibly hostile conditions of the Hadean Eon. One of the most dramatic events in Earth's early history was the formation of the Moon. The most widely accepted theory is the giant impact hypothesis. This theory suggests that a Mars-sized object, which we call Theia, collided with the young Earth. This impact was cataclysmic, melting Theia and blasting huge amounts of Earth's mantle into space. This debris, caught in Earth's gravity, coalesced over time to form the Moon. The impact that formed the Moon had a profound effect on Earth. It tilted Earth's axis, which is why we have seasons. It also contributed to the formation of Earth's magnetic field, which protects us from harmful solar radiation. The Moon also stabilizes Earth's rotation, preventing wild swings in our climate. This event, while incredibly destructive, was essential in shaping Earth into the habitable planet we know today. The early atmosphere of the Hadean Eon was vastly different from the air we breathe today. It was a toxic mixture of gases including methane, ammonia, carbon dioxide, and water vapor. There was little to no free oxygen. This early atmosphere was formed through a process called outgassing. As the Earth's molten surface cooled, gases trapped within the planet were released through volcanic eruptions. These gases formed the earliest atmosphere, a thick, steamy blanket around the young planet. This early atmosphere played a crucial role in the development of the Earth. It helped to trap heat, keeping the planet warm enough for liquid water to exist. This was essential for the eventual emergence of life. However, this early atmosphere was also incredibly hostile. The lack of oxygen, combined with the presence of toxic gases, would have made it impossible for life as we know it to survive. It wasn't until much later, with the evolution of photosynthetic organisms, that oxygen began to accumulate in the atmosphere, paving the way for the evolution of more complex life.